Hello, my name is Sam Hawkins, and this is my Physics 2211 lab report for the Create Your Own lab experiment. For this lab, I'm going to be calculating work based on um, objects falling from different height and calculating the work that they do on the floor. So a couple equations we're gonna need. Obviously, the work equals force times distance equation, which is part of the energy equations. And pretty much that equation comes from the just the original properties of force, which is obviously the force equals mass times acceleration, or force equals change momentum over change time. And then obviously work is delta energy, which is once again force times distance. So for this lab, I'm pretty much just going to give various heights and calculate the work done on the floor. So for the first one, I have a height of 1.2 feet, dropping a pull cue ball. So I'll just let y'all watch that a couple times. You can see it hit the floor, bounce a little bit, do all that. So like I said, I dropped the ball from 1.2 feet, and we're calculating the work on the floor, not the work on the ball. So we don't even need to calculate the force done on the floor because, as we can see in this video, the floor does not move at all. So we can conclude that from this height, the work done on the floor is 0. Moving on to the next slide. This video, this one's 2.9 feet. You can see a little bit further up the cue stick. Once again, I'll just play the video a couple of times for you. You can see it gets faster, bounces a little higher when it hits the ground. But overall, it's a pretty similar thing that we see. Obviously, knowing that it's shot from 2.9 feet this time, we know that it's going to be going faster and it's going to be hitting the floor with a higher force. But once again, if you look closely, the floor does not move. So we can once again conclude that the ball did 0 work on the floor. Here's my last video. It's 5.4 feet. Once again, watch it drop. This time, once again, it's going to bounce a lot higher. You can see it keep bouncing multiple times instead of that like 1 or 2 bounces it had on the other ones. Obviously, with this one, the ball is coming down pretty fast and it's doing a good bit of work. Has a good bit of force in it. A lot of momentum as it hits the floor. Obviously, it looks like about half of that momentum is redirected back up as it jumps about halfway back up the pull cue. But once again, we're looking at the floor, and for the third time, it seems that the floor did not move, which means that, like all the other ones, there's energy from the pool ball dissipating, and to sound, obviously, you can expect that some of it's putting off heat as it makes contact with the floor. But as we saw before, and we're seeing again, the ball is not doing any work on the floor. So pretty much with these things, I can draw a pretty clear conclusion that a pool ball dropped from any height that you can expect to drop a pool ball from inside your house is not going to be enough for the pool ball to do work on the floor. I think even if you had a pool ball at terminal velocity, this is on the first floor of a house, so it's got obviously concrete under it. I think that assuming that you are on a first floor, there is no speed within the terminal velocity that a pool ball could go that would do work on the floor. However, if you're in a place with really bad flooring, maybe higher up in a building, I think it would be possible to eventually do work on the floor, make it shake, or even just pierce right through it. But just for the reasons of the normal uses of a pool ball, especially on the first floor of a house, I don't think that there's ever a situation you could put yourself in where you would make a pool ball do work on the floor. So just as a conclusion, going back to this slide, work is force times distance traveled. Since the floor in all these situations didn't travel any distance, we can conclude that the pool ball never did work.